This is activity 2 in packet 2 for electricity. You're going to notice that at the top here we have a capacitor charging, and I have that labeled here as charging, and then we have the capacitor discharging. Now these dots here are supposed to represent a compass set up in that circuit, and then a compass set up in this circuit, 3 different places, and they're labeled A through G. So you see those labeled down here. So the thing that we want to do is make predictions first. Will the bulbs light? So will the bulbs light when we do charging? Either yes or no. For bulb 1 up here, bulb 2 is down here. And then will they light when we discharge? Ooh, we just saw this in the previous lab, so you should know the correct answer for those. Now, the next thing is we're going to do is look at the compass deflection. So we're going to look at the deflection. They're asking us to look at all of these areas. I'm only going to do one of them because it gets kind of difficult to set all of these up and video this. And so we have CW for clockwise and CCW for counterclockwise. So at position A, I'm asking you to predict, is the compass going to deflect clockwise or counterclockwise? B, C, D, E is right here, F is here, and G is here. So just go ahead and circle, or is there going to be no deflection? So we're asking you to look at that. Now, I'm going to set this up, and we're going to have to look really close, and I'm going to mark it on the board what happens, and then we'll go through the conclusions. So to begin with, we're going to charge up the capacitor. So I have the battery pack in here. We have the 2 light bulbs, and we know when we connect this, so we want to be looking at this compass right here, and I'm going to mark it with a marker. What happens to the compass needle. So we know how this bulb lights up just briefly, so we're going to have to record this very quickly. So I'm going to connect this. We should see those bulbs light up just for a moment, and then they go out. So if I look at this, oh, it looks like the compass needle went that direction. It's going like this. So I would say that is counterclockwise. Now, I'm not going to do every different point here. I did this point right now. This would have been position C on your thing. I'm not going to do every point. We've done this before where we used a battery and we checked the deflection. They were all the same. So on here, wouldn't we make a good guess to say that they are all going to be the same? That would be a good prediction. They are all the same. When we are charging up the capacitor, so over here, we could say they should all be going counterclockwise, all of them, because every position in this, and that would have been for the first one for charging, would have been letters A through D. Okay, now I want to do the same thing. So this capacitor is charged up. I want to discharge it, and then let's see what happens to the compass needle. So let's say I'm looking at position G here. So I'm going to just hook this up, discharge it, and we're going to watch this. And we should be able to see these lights flicker on just briefly. Well, went the opposite direction. It looks like it went like this. That compass needle just deflected just slightly. So these were clockwise. So for positions for the discharging, it would have been clockwise. So that would have been letters E, F, and G. A, B, and C, and D should have been counterclockwise because that's when it was charging. Discharging, isn't that the reverse? So that's going to be clockwise. So that means charge must be moving in one direction when it is charging, and then it reverses that direction when it discharges. So we're going to make a few conclusions here about what is happening in the wires in our circuits. So these circuits were our charging and discharging. Okay? So we can say conclusions. Our first conclusion is we didn't look at all of the compass needles, but we know from what we've done before that the compass needle deflects in the same direction in one single circuit. So our first one we're going to say is that charge flows in the same direction in all the wires in a specific circuit. So when we had it charging, the compass needle deflection would have all been the same. When it was discharging, the compass needle deflection would have been the opposite, so within a specific circuit. Okay. When we reverse, so this was discharging, the compass needle deflected in the opposite direction. The capacitor. The capacitor stores charge until it is discharged. So in other words, it holds the charge until it discharges. I have two different capacitors. I have a capacitor that is like this size, and then I have one that's this size. So you can see if I use a bigger capacitor, this is going to store more charge than this. So in a capacitor, these two terminals at the top are not connected together. You were supposed to read that reading, and it told you that there's insulating stuff in between there. So they are not connected. Now, this is an important piece. The charge that comes in any circuit, and we're going to call it the mobile charge because it does move, the mobile charge originates in all conducting materials in a closed loop. So that's where our charge is originating. Okay, so what does that mean? That means the charge that is already found in this metal piece right here, the charge is already found inside this plastic, the wire here. The charge is already found in these metal parts on the socket. It's already there. A good example I can think of is when you turn on the faucet, you get water right now. You don't have to wait for the water to be pumped from the city water plant all the way through the pipes to your house. So in other words, water is already in all the pipes leading up to your house. It's in the pipes leading up to your sink. So when you turn it on, it's right there. So that's the same thing here. Charge is already right here, and that's why in a circuit, this light lights at the same time that this light, because the charge is already right there at the bulb. The battery just supplies the force to make it move. Okay? So the battery does not make charge. The battery just is a force that makes charge move. So that's the difference. So for terms with this, there are two terms that we're going to put down. Here are two terms. A positive capacitor plate and this is the top plate on the capacitor. So that's the positive one, and then there's the negative capacitor plate. And this is the bottom plate on the capacitor. Now, so we have these two terminals right here. One is positive, one is negative. If you could see, there is a plus sign by this one and a negative sign by this one. So if I drew a picture out, and I'm going to do a schematic diagram. So if I had 3 batteries in here, this is just easier to do this. And then if I did like round bulbs, and then over here's my capacitor. Remember, it's just 2 plates, 2 parallel lines, and then here's another round bulb connected here. We would say that on this diagram, let me get this to show up here, the top plate, we call this the top plate, this is the positive. The bottom plate, this is the negative. So that's how we would assign that. So on a capacitor, you have these 2 different terminals. One's negative and one's positive. And then notice how there's a gap here. That's because there's insulating material in there. Those 2 plates are not connected. And so charge does not go through the capacitor. That's why the light bulb only lights up for a brief time, because the charge flows through here quickly, and once it builds up here, it stops. It can't hold anymore. So this concludes activity 2.